Okay, I've adjusted the lighting a little bit. It's still really hard to see the difference between the pink and the red, but I'm going to talk a little bit about the topology of the puzzle, in particular what's adjacent to what. So in the interface, it's really obvious that these 4 stickers are adjacent to these 4 stickers. For the other parts of the puzzle, it's a little bit less obvious, but these white stickers are all adjacent to each other. The reds are together, the yellows are together, the purples are together. And so if you were to do this sort of roll operation, you have not changed the state of the puzzle. You've actually done a 4-dimensional rotation of the puzzle, and you can think of that as a pair of twists, 1, 2. And if you think about a regular 2x2x2 Rubik's Cube, I'll pretend this is one of those. If you were to rotate the top slice and then rotate the bottom slice in the same direction, that would basically be the same thing as reorienting the whole puzzle. So that's what's going on there. But you can see that these adjacencies can be moved around in such a way that doesn't change the state of the puzzle. So this is where it starts getting a little interesting. It's really easy to see that this is the blue face, because we can see all 8 blue stickers are very clearly visible, and we can see the kind of things that are hanging down over the edge where the blue face is adjacent to the yellow, red, white, orange, purple, and pink faces. But it's a little bit trickier to see that let's say, for example, this is the white face. So I'm gonna demonstrate that by doing a series of rolls. So first I'm gonna do this roll. So I'm gonna fold this down, and then I'm gonna turn this, and I'm gonna roll this little bit up here, and I'm gonna roll this little bit around like that, and then I'm gonna roll the whole thing around. And now it's really obvious that this is the white face, because again we see all 8 white stickers around the outer corners, and we see solid colors of all the places where the white face intercepts the other faces. So let me roll this back around so that green is on the outside, and then I'm going to unfold this back so that I have the white face in its previous position, and there we're back to where we started. So that manipulation that I just did is the basis for my gyroscopic rotation. So I had the great pleasure of having dinner with Melinda last night. I hadn't seen her in person for more than 20 years, and I just happened to be in San Francisco for a conference, and we got together and talked about the puzzle, which was great fun. So I learned the term gyroscopic rotation for the rotation that takes moves some other slices to the top and bottom position. It's really easy to move the front face to the left. I just do this. I can move the inner face to the left too with this roll, and now the face that was the inner face is the left. I can even switch the inner face and the outer face by doing that, or equivalently doing that. So these are all 4-dimensional rotations, but the hard thing to do is, suppose I wanted to have purple and pink on the top and bottom instead of blue and green. So I'm going to repeat my face isolation, which is to flop this down, and then I'm going to put purple on the side here. And imagine that you were looking at a mirror, that you had mirrors on the top and the side, so that here we've got blue around the corners. But if we had mirrors, then you could look at this as now the lower left-hand corner of a square that consists of purple, blue, another blue triangle here, purple on the outside, another blue triangle here, and purple on the outside. And so you could see that this half of this square could be the outside, and we get that again with the roll. It's hard to do it without blocking the view with my fingers. And there's our purple face. So, whoops. So let me undo that. And I'm going to do a little optimization. This kind of roll is a little bit hard to do. And so instead of doing that, I'm going to do this. I'm going to flip this up, and then I'm going to take this top piece and I'm going to just bring it down to the bottom. So that's exactly the same thing as rolling those two halves independently. So once you've done, now I'm going to put this back on the top, and I'm going to fold this down the other way. So basically the roll is to take the thing that you want to be on the outside and put it on the sides, and then the muscle memory move that I do is I flip the front up, take the top part on the bottom, and then flip the bottom back like this, and that's how I do my roll. So my gyro rotation, you can see, let me see, this one has blue on the bottom and yellow in the middle, so I'll just unfold, put these back together. So my gyroscopic rotation is to perform that basically face isolation on the two sides in parallel. And I do it kind of like the trick of not doing the individual rolls, but taking the top off, putting on the bottom. I've sort of optimized for that. So I'm going to show you what this looks like. I'm going to pull these apart and flip them upside down like this. And now I'm going to do this fold over like this. And now I'm going to fold this up, pop this around, fold this back, and there is my gyroscopic rotation. So I really like this. It's only 5 moves if you count the symmetrical folding on both sides as one move. And it doesn't have any correction moves. I don't have to do any kind of, 1, 2, 3. I don't have to do anything like that. It just comes out fully correct. And it's also very easy to reverse. I could reverse it in different ways. I could move blue and green back to the top, to the sides, and hold it vertically. But I can also hold it horizontally just the way I was. And I can take the back half and fold it down and pop the bottom row, put it here, and then flop this over, and then open this back up and do this restack that is also flipping upside down, and I've restored to my original configuration. So that is my gyroscopic move.